Okay, this is lesson 51. We're doing negative exponents and scientific notation for small numbers. Okay, so when we talk about negative exponents, the first thing we need to talk about is the negative exponent law. Okay, and the negative exponent law looks like this. Okay, if we have, oops, let me erase this. Okay, if we have an exponent, or a base, okay, that's raised to a negative exponent, okay, then that is the same as taking that and flipping it over, or making it like a reciprocal almost, where we put 1 over x, and then it's to the first power, but the exponent, notice, is positive. Okay, so x to the negative 1 is the same as 1 over x to the positive 1. So likewise, we could have 2 to the negative third power, and that is equal to 1 over 2 to the positive third power. Okay, which is also equal to 1 over the 2 times 2 times 2 power, or 1 to the 8th. Okay, so 2 to the negative third power is the same as 1 over 2 to the third power, or 1 to the 8th. Okay, 10 to the negative second power is 1 over 10 squared, which is the same as 1 over 10 times 10, which is the same as 1 over 100. Okay? So, again, any negative exponent can be changed to a positive exponent by flipping it to the other side of a fraction sign. Okay? So, let's go on to some more examples. Example 1 says, which of the following does not equal 10 to the negative third? Okay, well, let's look at our negative exponent law here. We know that 10 to the negative first is the same as 1 over 10 to the first power, or 1 over 10. Okay, likewise, 10 to the negative second power is 1 over 10 to the second, which is 1 over 10 times 10, which is the same as 1 over 100. Okay, so then 10 to the negative third power would be the same as 1 over 10 to the third. Okay, so we know that choice A is not correct because that is equal. Well, that's the same as 1 over 10 times 10 times 10, which is 1 over 1,000. Okay, so that rules out this example. Well, 1 over 1,000 as a decimal, let's try that. 1 over 1,000. Well, we know 1,000 doesn't go into 1, so we put a point. It doesn't go into 10. It doesn't go into 100, but it goes into 1,000 one time, so it's 0.001. So the answer is D. Okay? 10 to the negative third is not equal to negative 1,000. All right, let's keep moving on. All right, and up here we got objective 1, which is to simplify expressions using negative exponents. So, find each missing exponent. So part A, 10 to the negative second times 10 to the negative fourth. Remember, when we have a problem that looks like this, okay, we keep the same base, and we add the exponents. So that's negative 2 plus negative 4. Sorry about that. Well, negative 2 plus negative 4 is negative 6, so it's 10 to the negative 6th power. Okay, so our missing exponent is negative 6. Right there. B, when we look at this, remember, this is a division problem, so we are going to subtract the exponent. So this is 10 minus 2, and we take away the negative 4. Well, that's the same as 10, and then we have a subtraction problem here. So remember, we changed subtraction problems to addition. So that's the same as negative 2 plus sign. The minus changes to its opposite, which is plus. So this number changes to its opposite, which is 4. And 10 to the negative 2 plus 4, well, negative 2 plus 4 is positive 2. So that's our missing exponent there, positive 2. Okay? Alright, let's keep going on to more examples. Example 3 says to simplify, we want to simplify 2 to the negative third power. Okay, so if I write 2 to the negative third power, remember that is equal to 1 over 2 to the positive third power, which is equal to 1 over 2 to the third is 2 times 2 times 2, which is the same as 1 to the 8th, or sorry, 1/8. Okay, so this is all the way simplified. Notice I didn't leave it with the exponents because it says to simplify. Now sometimes it might tell you rewrite with positive exponents. If it says to rewrite with positive exponents, this would be my answer because I've got positive exponents now. But when it says simplify, I want to break it all the way down here. Okay, now let's look at B. B says negative 2 to the third power. Well, my exponent's positive, so I don't need to do any flipping over like I did up here. Okay, so since the exponent is positive, I'm just going to take negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4, and 4 times negative 2 equals negative 8. Okay, so notice here the only time that we flip this over to the bottom half, okay, or flip it over to the opposite side of the fraction bar, is when the exponent is negative. It doesn't matter what the number out front is, okay? It's when the exponent is negative that we flip it over. Okay, let's keep on moving on. Okay, example 4, this is 3 squared times 3 to the negative second. Well, I've got 3 squared times 3 to the negative second. I'm going to show you two different ways to solve this. Okay, one way is to use the negative exponent rule we just learned. Okay, so 3 squared times 3 to the negative second is the same as 3 squared times 1 over 3 to the second power. Okay, well 3 squared is the same as 3 squared over 1. Okay, so 3 squared over 1 is the same as 3 squared. 1 over 3 squared is the same as 3 to the negative second. We multiply this, we can multiply this like fractions, okay, where I get 3 squared times 1 on top. Okay, well, let's go ahead and change this. 3 squared is 9 over 1, and we're multiplying that by 1 over, and then 3 squared is 9. So 9 over 1 times 1 over 9, those cancel, and leaves me with just 1 over 1, or 1. Okay, we can also do this using the exponent rules that we learned, where we're taking the same base and multiplying together. So this is the same as 3 times 2 plus negative 2. Or 3 to the 2 plus negative 2 power, sorry. And that's the same as 3, and then 2 plus negative 2 is 0. And we know that anything to the 0 power is 1. So there's two different ways of solving the same exact problem. Okay? You can pick whichever method you feel most comfortable with. Let's keep on moving on. Lots of examples in this lesson. Okay, example 5 says to express with positive exponents and simplify. Okay, and we got some steps over here. So the first step says to write the expression as a fraction. So I'm just going to go ahead and rewrite the expression I'm given. Y x squared, whoops, sorry. Let's try that again. Okay, so it's 2x to the first y, x squared, y to the negative second, and then z. Okay? Now, write as a fraction simply means to put that over 1. Okay? Now, step 2 says to shift any negative exponents to the opposite side of the division bar. Okay? So anything with negative exponents has to go to the opposite side of this bar. So if it's on top, it has to go to the bottom. If it's on bottom with a negative exponent, it goes to the top. So the 2 is going to stay put on top. Okay, it's not going anywhere. My 1 is going to stay put on the bottom because they don't have exponents with them. Now x to the negative first, that has to shift to the opposite side, so that's got to go down to the bottom. So that's going to go down here, and the exponent changes to positive 1. Okay? Well, this y is going to stay put because it doesn't have an exponent with it. This x squared is going to stay put because the 2 is a positive. This y to the negative second is going to go to the bottom, and the exponent is going to be positive, so it's going to be y squared. And the z is going to stay on top because it has no exponent. Okay, so again, notice the number or the expressions with negative exponents move to the bottom and made the exponents positive. Okay, now we need to simplify. Well, I'm going to go ahead and write this all out here just to see what it looks like. So on top, I've got 2 times y, and then I've got 2 x's, and I've got a z. On the bottom, I've got a 1 times 1x and 2 y's. So I can cross out anything that's the same on top and bottom. So I can cross out one set of x's and one set of y's. So that leaves me on top with, now I've got a 2, an x, and a z. And on the bottom, I've got a 1 and a y. Okay? Okay, we can also write that as 2xz over just y, because we don't need the 1 on the bottom if there's something else there with it. Okay, so those are the same thing because 1y is the same as just y. Let's go on to another example. Now this is the same type of problem as the last one. Okay, so first thing is to write as a fraction. Well, it's already written as a fraction for us, so we don't need to do anything else. So now what we need to do is shift any negative exponents to the opposite side of the bar. Okay, so I'm just going to look at this in order here. So let's do the top ones first. So I've got negative 2. It has no exponent. Okay, so just because the number is negative doesn't mean we switch it. It's the exponent that has to be negative. So there's no exponent here, so it stays on top. This x to the negative second is going to go to the bottom and become x squared, okay, a positive x squared. This y to the third is going to stay on top. Okay? Well then down on the bottom we have an x squared. This is already positive, so it stays on the bottom. It doesn't go anywhere. And this y to the negative third is a negative, so we have to switch it to the opposite side of the bar, so it's going to go up to the top because the exponent is negative. And of course, when we switch it to the opposite side, the exponent becomes positive. Okay, so now we got a negative 2 with 2y to the thirds on top. So that's like negative 2 times 3y's times another 3y's. And on bottom, that's like 2x's times 2 more x's. So on top I've got a negative 2, and then I've got 6y's, so that's y to the 6th power. And on bottom I've got 4 x's, x to the 4th. And this is simplified. So I am done. Okay? And we got 2 more examples left, I think. Or, sorry, maybe 3 more examples.